Welcome to the lesson on vectors, Word2Vec, making vectors from words. So basically the idea is computers aren't the best at working with words. They much prefer and they're much better at numbers. So the solution is, or has been, to convert words into numbers. And not only numbers, but lists of numbers. For example, let's say you want to tell me where you are. There's two ways to do it. You can say, hey, cross the street and make a left and go down this alley. Or you can just open your phone, click the spot, and send me the GPS coordinates, right? The latitude and the longitude. So that latitude and longitude is a list of two numbers. And that list of numbers is called a vector. So a vector is a list of numbers. And in machine learning and AI, the main breakthrough 13 years ago was to convert words into vectors. So without further ado, we're going to do it right now. Okay. So this is a vector right here. This is a four-dimensional vector. Four-dimensional meaning it has four numbers, right? We got the latitude, which is like the length. Then we got the longitude, which is like the width. And here we got the height. So let's say I want you to meet me at the Empire State Building at the top on January 1st, 2030 at midnight. Probably a great view there and some cool fireworks. So instead of saying that long sentence, I can just give you a vector of the latitude, the longitude, the height, and the time, okay? So the latitude here is 40.74, blah, blah, blah. Longitude is 73.98, blah, blah, blah. The height is 443.2 meters above the street level. And the time is 189.3474 times 10 to the 7th power seconds. So that funky number for time, what that is, that's what's called a Unix timestamp. That's actually the number of seconds since January 1st, 1970. So they just picked that date, and we count the time in Unix from the seconds since that date. So we've got a vector, a four-dimensional vector of the latitude, the longitude, the height, and the time. And when we look at the numbers, here are the numbers for that vector, okay? So that's our first vector. All right. The best way to understand this is to just do it and get your hands dirty. So we're going to start doing it. And the cool thing, I'll give you your hook, is we can do math with these vectors. We can add them, we can subtract them, we can do like full-on algebra. It's incredible. So without further ado, okay, the first thing you're going to want to do is install Gensim. Now, if you're a Bike Club member, and you are a Bike Club member, right? One of your perks is it comes pre-installed with the code setup that you got, so you don't have to worry about any of that. But for all you non-Bike Clubbers out there, you're going to need to install Gensim. So you're going to want to put that in your requirements, .text, for example. Okay? Anyway. So we're going to load it. So from gensim.models, we're going to import Word2Vec. Word2Vec is the Google library, and it means from words to vectors. So from words to lists of numbers. And they called it Word2Vec for short. It's kind of a cool name, yeah. Nerd name. All right. So why don't you go ahead and load that. It might take some time. And first, we're going to need to have some text, yeah? So we're going to have two sentences. There's an English expression, you can't add apples and oranges. That means it makes no sense to add things that don't go together or in a different category. But we're going to do just that today. So we've got the sentence, you're adding apples and oranges. And let me show you right here. So this format here, this is like a list of words, basically, a list of strings. So each word here is a string separated by a comma. They're all lowercase. There's no punctuation. So that's that sentence right there, which is just a list of words. And we've got sentence number 2, which is this is far out. Because it is kind of far out. We're talking about multi-dimensional space here, right? I just gave you an example of 4 dimensions, but these things get up to like, hundreds of dimensions. No joke. And so we got 2 sentences, which is, so we've got a list, right, of 2 lists of strings of words. Okay. And now we're going to load the model. Now, a lot of this is going to sound like coming really fast and might give you a headache or something. It's okay. Just bear with it. Just kind of grind through it. It's going to be a slog at first, but one morning it's just going to click, and you're going to be so glad you stuck with it, okay? So let's keep going forward. And what we're going to do is we're going to train the model, the language model, okay? So this model is using library Word2Vec, this class here called Word2Vec, and we're going to use our sentences right here. Vector size is 4, which means that these are 4-dimensional vectors, which means that each have 4 numbers, just like our example up here. Again, these vectors, ideally, they've got like hundreds of dimensions, hundreds of numbers, but for training purposes, we're just using 4 right now, okay? Minimum count is 1. That means we're going to use every word if it appears at least once. So we're going to use every word without exception. When you train on billions and billions of words, usually they just take the ones that occur most frequently. They cut off the ones that are just one-off, so to speak. Okay, so now we're going to train our model. That shouldn't take too much time. You can click this little play button here to run your code. Let me just clean up the mess here. Sorry about this mess. Clear. You can type clear to clean it up. See? So there we go. I trained the model. It's done. It'll tell you if there's a problem, basically. If it doesn't tell you anything, that means there's no problem. All right. So now we're going to get ready to add apples and oranges. So to do that, to add apples and oranges, we're going to need an apples vector and an oranges vector. A list of numbers that represents apples and a list of numbers that represents oranges, okay? So that's what this is. The apples vector is where the model is going to get the vector for apples in scare quotes, and then the oranges vector is where the model is going to get the vector for oranges in scare quotes, okay? And then we're going to print it out to the terminal over here. That's what that print means, okay? So we're going to hit play. And there you go. This is the apples vector. Let me show you right here. Okay, these 4 numbers. And here is the oranges vector, which is this 4 numbers. So we've got a 4-dimensional vector for apples and a 4-dimensional vector for oranges, okay? 4 numbers for each. Got it? And that's it. That's how you get vectors and numbers. Word2Vec. And now the fun starts. As promised, we're going to do the algebra. Let me give you the hook. So you don't think it's over yet. The show's not over. So what these Google engineers discovered in 2013, somewhat to their surprise, is that you can do arithmetic with these numbers and it makes sense. So the famous example is the word king minus the word for man plus the word for woman. Okay, so let's work through it. We've got a king minus the word for man. So what does king minus man mean? I would say like royalty, right? So it's a royal, but we don't know if it's a king or a queen or a prince or a princess, whatever. So I would say king minus man is royalty, or sovereign, if you will, and then plus woman. King minus man plus woman. It's a queen, right? Think about it. And what you're going to see is that actually works. We're going to do this math, which means you can do algebra with words, which is incredible. I don't want to oversell it, though, but just watch. And do better than watch. Just do it. Okay, so the first thing we're going to do is import this Gensim downloader, which is going to download a pre-trained model. Now, if you try to, we just trained a model, right, with those 2 sentences. But if these are like billions and billions of words, so at least 5 billion plus Wikipedia stuff, If you do it on your laptop, it's going to take you forever. Probably melt your computer or something. So to save time, we're going to use the pre-trained ones from Google. Okay? I mean, from Stanford University, I'm sorry. So here is the model. We're going to use a downloader to load. It's called Glove Wiki GigaWord 50. Okay? And so let's do that. And see if it loads. It's going to take a little while to download here. And done. So it took a couple seconds here. And now here's where the fun starts. We get to add apples and oranges. So we're going to ask the model to find the most similar word, okay, the most similar word to apples plus oranges. The way this thing works is the positive here is for addition, okay? So apples plus oranges means add apples and oranges. So positive apples, positive oranges means add apples and oranges, okay? And then print it out to the terminal. So if you ever wanted to know what happens if you add apples and oranges, you're about to find out. Drum roll, please. The suspense is killing me. It's thinking hard. And here we go. You've got the answer. The answer is when you add apples and oranges, you get peaches, apparently. That's got a score of 0.88 right here. The next highest, the next most similar, has got a similarity score of 0.86. And then you got strawberries, etc. So the result of adding apples and oranges is peaches. Just now you know. From the best minds in the world of AI. All right. Now we'll do that famous experiment, which is what you came here for, right? Everyone's going to ask you about it. Did you do the thing? Did you do the king-queen experiment? And you can say you did, that you did it. Here we go. So, again, to recap, the most famous line here is king minus man plus woman equals queen, right? So, positive king and woman, okay? So we've got king and then negative man. So king minus man plus woman. All right, the order of operations doesn't really matter here. So, all you math whizzes out there, does order of operations matter for addition and subtraction? I don't think so. But, you know, maybe I'm showing my ignorance. Correct me if I'm wrong. It's been a long day. Anyway, king minus man plus woman. And without further ado, here we go. Hit play. Hit run, I'm sorry. And it's coming. Dun, 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 dun. We just did it, guys. The famous experiment. It's a queen, right? With the similarity score of 0.85. And then there's some other ones in here that aren't really applicable. An interesting one is you see Elizabeth. So there was Queen Elizabeth, right, in England. So that's cool. Also princess. So anyway, now you know. Let's do some more. Think about this one. Positive is Washington. Negative is America. Positive is Poland. So what is Washington, as in Washington, D.C., minus USA, minus America, plus Poland? Think about it. Washington minus America plus Poland equals, let's find out what the computer says. It's thinking, and here we go. Warsaw. Right, because Washington is the capital of America, and Warsaw is the capital of Poland. So America is to Washington as Poland is to Warsaw. Okay, and one more, and we're done, I promise. You guys can go walk off that headache. But trust me, this really does get easier. It really does. You're almost there. Okay. So what is faster minus fast plus hard? So faster minus fast plus hard. Right? This is kind of like a grammatical thing more. Well, let's find out. Faster minus fast plus hard is, drum roll, harder. Think about it. Okay, guys, so you've got the code here. This is lesson 3. It's in the lessons folder here. Go to lesson 3. And you can just copy paste this and do your own, right? So we can do slower here, slow here, and then good, for example, right? So you can just do your own, have fun, do your own experiments. This is the core concept that all this AI and LLM stuff is going to be built on. See, it's better. There's the Great Books program. I've maybe heard of it, from the University of Chicago, which also has a branch at St. John's University in Annapolis, Maryland, which is actually where I'm from. Anyway, their theory was you should read the original sources, primary sources, and rediscover with the original discoverer. So in that spirit, I've got the papers here from Mickelwolf and company. Mickelwolf et al., their 2013 papers, there were 2 of them. I've got here, if you click the README, under Truth, under Mickelwolf, under 2013A and 13B, you've got the README files. And these are just kind of like study guides, kind of written for every man to kind of internalize how these papers work. So if you've got the time and bandwidth, I'd highly recommend reading the study guides. I'm going to try to get the translations in at some point, but they're not in there yet. So you guys can read in other languages. Okay, so to recap. Today we did vectors. Vectors are lists of words that are used to represent, vectors are lists of numbers that are used to represent words. We can use vectors to do algebraic operations, like addition and subtraction, for example, arithmetic. And the fact that you can do these operations and it makes sense was surprising to researchers 13 years ago. And based on that, we're going to keep building in our adventure, mastering large language models, or LLMs. Thank you for your time. Congratulations for making it through the end. Peace out. See ya.